very firstly, what is the basics? What is the function of a pipeline? So a pipeline is used for the transmission of large quantities of, in our case, oil or gas from a source to a destination for further processing, refining and storage. So I think the main thing is what we're trying to do is move large quantities of oil and gas. We're not necessarily trying to process it at all. Pipelines will traverse large distances, and most countries have fairly extensive networks of pipelines. They can be either above ground or below ground. Primarily for moving large distances, usually that we aim for below ground. That keeps pipelines out of sight and safe from interference from external parties. Sometimes pipelines need to cross bodies of water. For example, if we're going cross-country under a river or the like, where we will typically tunnel right underneath, or if we're out at sea offshore, we will need to lay pipelines in the water or trenched on the bottom of the seabed. And they are vital to meet the energy needs of most countries these days, and they're a very sensible alternative to road transportation, rail transportation that we might have used in the past for oil and gas, and they're essential for economic growth. Without the energy from those fuels. Here's an example of a particularly special one we'll look at in a little bit of detail later, the Trans-Alaska pipeline. That's one, I suppose most notably is, in this instance, a lot of it is above ground. What I'll do is just go through a couple of major pipelines and throw some statistics at you for those to give an idea of some of the pipelines that are applicable. The Trans-Alaska pipeline travels from the very north, Prudhoe Bay. There's some oil fields out there, down to Valdez. Commodity transported there is crude oil. Length of that particular pipeline, 800 miles. Was constructed in the early 70s. Quite a few challenges back then with the extreme climate, the permafrost and environmental impacts, and were taken seriously probably for the first time in pipeline work, and that marked quite a turning point in how we dealt with pipelines and environmental impacts. Some statistics there on oil flows, and back then significant amount of money, $7.7 billion or thereabouts, and I think that's US dollars back in the mid-70s. Oops. Another one, Baku, Tbilisi, Xi'an, Caspian Sea down to the Mediterranean. Once again, crude oil pipeline, length of 1,100 miles, constructed in the early 2000s. $3.6 billion US. That pipeline traverses a number of mountain ranges, railways and water bodies. And significant reduction there of tankers through the Bosphorus Strait. Over in China, the west-to-east gas system across to Shanghai. Natural gas, 2,500 miles long, cost of $500 billion, also constructed in the early 2000s. Many challenges there, mountain ranges, rivers. So that's a bit of a taste of a few of the major pipelines, but by no means do everything we're talking about is also applicable to much smaller pipelines as well. What affects the design and construction of pipelines? Nature of the fluid being transported, liquid or gas, the fluid properties, the volume flow rate needed, length of the pipeline, the terrain, medium, that is, are we underwater, so out to sea, offshore, or onshore soil. That will obviously affect how we design and build the pipeline. Any extreme climate conditions, heat out in our deserts here in Australia and other places, or cold, we have the example of Alaska there. And any other environmental constraints or impacts. We need to ensure we use the codes and pipeline codes, various standards for all the components that make up those pipelines, and the regulations that govern the different aspects of pipeline work. Do we have seismic, volcanic conditions? Do we need to cross flood plains? Is there a potential for flooding? Then we obviously need to look at the economics to make sure those pipelines are viable. And then materials of construction. That will obviously be vital. Make sure we firstly select the right materials for corrosion resistance, strength, ductility, and economics, clearly.